talking about linear equations that from the name linear, their graphs are straight lines. Okay, so y equals x plus 3 matches y equals mx plus c. Okay, which is this the basic, what do you call it, sample for linear equations. So the only straight line I can see here, oh, there are two straight lines. Okay, that's quite tricky. So let's not fall for it. Now, sorry, before I go on, let me say something. The first one, let's go back to the first one. Y equals x squared minus 4x. Remember, I said something that quadratic equations are simply equations that the highest power of x in them is 2. Okay, the highest power of x is 2. And so you look at this guy, it has y equals x squared minus 4x. So the highest power of x there is actually 2. So it fits the description of a quadratic equation. However, quadratic equations are usually divided into two groups. The ones whose coefficient of x squared and their coefficients are negative, and the ones whose coefficient of x squared is positive. Now, what do I mean by coefficient? The number that's multiplying x squared. Now, if you look at this we have in front of us, it's y equals x squared minus 4x. So that means its coefficient is positive, which means that its graph would open towards the positive y-axis. And that's the reason why I'm even more sure that B is correct, because this graph opens up, you know, as in it's facing open towards the positive y-axis. The positive y-axis we know is from 0 upwards, okay? And the negative y-axis is from 0 downward. And so that means that if we had a quadratic equation in this question that had something like minus 2x squared minus 4x, then in that case, the graph would no longer look like this one in B. It will be facing downwards. It will be opening up downwards towards the negative y-axis. Okay, that's the, let me see if I can draw a sketch of how it would have looked. This is how it would have looked. Don't worry, I'm going to erase it. This is how it would have looked if the coefficient of x squared, you know, were minus. Remember, that is the determining factor, the coefficient of x squared. Okay, so let me wipe it off because that may be misleading. I wonder where my eraser is. Okay, I've seen it. Okay. So let's wipe it off. Okay, so back to our linear equations. So for linear equations can also, just like quadratic equations, are in two groups. Linear equations too are in two groups. The first group, just like quadratic, are positive. The positive coefficient of x. And if you remember, what do you call it? Linear equations look like this. Y equals mx plus c. So what characterizes them is what? The coefficient of x. So now that m can be a positive number or it can be a negative number. So let's imagine it was positive. If it's positive, then it will be tilting towards the positive x-axis. That means the correct answer for this particular one, y equals x plus 3, is D. Okay, so that means the answer is D. Now, I know you are thinking, but we have another straight line there. So which one would it match for? I guess we'll soon see the one that would be correct for it. And that one will be the one whose coefficient of x is negative. And I think that's the last one here. So maybe we should just do it since we're sure of the answer. So because, look again, the coefficient of x for this last one is y equals 5 minus 2x. So remember, whenever we want to take the coefficient of a variable, always look at the sign in front of it. And in this case, the sign in front of 2 is minus. So guess what? the answer for this guy, for the last one, will be A. So now, you see, you might be wondering, why are we doing this? What we're doing is we're not guessing. Okay, we're basing our answers, our choices of answer on solid mathematical facts. We're not guessing. Had it been we had to guess, I would have been telling you that we're guessing, but we're not guessing. We're sure. Okay. So again, negative when the coefficient of x is negative for a linear equation. Remember, a linear equation is one whose highest power of x is 1. Okay. So if it's negative, it's going to tilt towards the negative x-axis. Whereas if it's positive, it's going to tilt towards the positive x-axis. All right. Okay. So let's move on now. So that means we're left with two more. The ones for y equals x cubed minus 2 and y equals 1 over x. I think we have seen the one for this 1 over x before. So which one would it be? So the only options we're left with now are C and E. So the answer must come out from those two. So let me see. For y equals 1 over x, the option is E. I'm going to confirm it. Just give me a minute. I'll confirm it. So it's going to be E. And that will now leave me with the last option for y equals x cubed. Now, x cubed is called the quartic equation. That's where the highest power of x is 3. Okay? So equations that look like that, their graphs are usually looking like what you have in C. Okay, so do you have any questions so far? Do you have any questions? Okay. Okay, I just wanted to, do you have an idea of the correct graphs for the last two that we just did? I just wanted to confirm it, if the choice that I took was correct. I think those last two. Okay, so
yeah, it's the other way around.
Okay, it's the other way around.
Yes.
Okay, so this one's on is C. Oh, yeah. That makes sense. Yes, let me wipe it off. That makes sense. I'll tell you what I just noticed now. I'll tell you what I just noticed. Come on, this thing doesn't want to wipe off.
Yeah, that's you typed it. You typed it.
Oh, because I typed it. Oh, ouch. Okay, should I overwrite? How do I overwrite it? Let me see.
You just deleted it.
Oh, yeah. Okay. Yes, that's true. Yes. Okay, so that would be C, right?
Yes.
And then the other one would be
E.
Okay. All right. So yeah, you know what I just discovered, what I just noticed. Just imagine x were to be 0. You wanted to find out what's the value of y when x is 0. Whenever the denominator of a fraction is 0, it gives us infinity, right? And infinity is usually looking like this, two separate graphs that will never meet because of infinity, and when x is equal to 0. So you don't have any representative value for y, because the graph will just keep going upwards, all the way upwards. Imagine if we wanted to represent infinity on y-axis. It's not possible, right?
Oh, no.
Yeah, it's not possible. So yes, so that's fine. Yes, you're correct. So I think we can move on. Okay, I'll try and see how fast we can be, and at the same time, not compromise on quality. Okay, so here we go. A number D is rounded to 1 decimal place. The result is 12.7. Complete the error interval for D. Okay, so what do you think will be the error interval for D? 12.7 is the, do we say, would that be 12.5? No, it's not going to be 12.5. Looks like, because this is a one decimal place thing. So it should,
It is
is error, yes, error this thing should also be in one decimal place. What do you think?
the 12.7, is that on the right side?
No, the 12.7 is the 12.7 is representing D itself. So it's saying what are the two values 12.7 would be in between. Do you understand?
Oh, okay.
Yes. So that's why I said that it's going to be definitely and usually you either have 0.5 minus 0.5 or plus 0.5 in this kind of scenario, but I'm not too sure of it. That's why I'm asking what you think about it. If we add 0.5 to this, we are going to have 13.2. And then if you subtract 0.5 from this, you're going to have 11. No, you're going to have 12.2, 13.2 and 12.2. Do you have the marking scheme with you there?
Yes, yes.
Okay. So what does the marking scheme, the math scheme say?
12.65
12.65. Okay.
on the left and then 12.75 on the right.
Okay. 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 I think I get it. So they use 0.05 instead of 0.5. Okay. Okay. Makes sense. 12.65 on the left. Okay. Let me see. Yeah. 12.75. Okay. All right. So let's look at number 27. Number 27 says Tamsin buys a house with a value of 150,000 pounds. The value of Tamsin's house increases by 4% each year. Okay, so take note of that. 4% each year. Rachel buys a house with a value of 160,000, and the value of Rachel's house increases by 1.5% each year. Okay. At the end of 2 years, whose house has the greater value? You must show how you get your answer. Okay. At the end of 2 years. Okay, so I think it's pretty straightforward, right? 4% is 0.04. 1.5% is 0.0, yeah, 0.015. So if we're to multiply that, are we allowed to use calculator for this? I think it's a calculator exam, right?
Yes, yes, it's calculated.
Okay, good. Okay, so this is what we're going to do. Rachel's house increases by 1.5% each year. Okay, so this is what we're going to do. We're going to have, let's have one side for Tamsin. So just have your calculator ready. And then we're going to have a separate side for Rachel. Okay. All right, so I think I'm going to have to use, okay, let's see if we can still be typing. All right, so for Tamsin, after the first year, what's the value? Says it increases by 4% each year. Okay, so we ideally, right? This is what we're supposed to do. Is the new value after the first year is going to be 150,123,000 plus 150,123 times 0.04. Okay, that's for term C, which this is going to be equal to what? So can you do this? Carry out the calculation in the brackets first, then we add 150,000 to it, that we get the new value.
$6,000.
100 and that's, did you say 6,000?
Yes.
Okay, that's for the one in the bracket, right?
Yes, yes.
Excellent. Okay, then how about the one, so since it's 6,000, so with that one that's outside, that's going to be 156,000, am I right?
Yes.
Okay, good. Okay, so now we're going to do the same thing. Second year, right? It's still 4%. So we're going to go 156,000 plus 156,000 times 0.04. Okay, so let's see. What's that going to give us?
Oh, 6,240.
6,240. So that's for the bracket, right?
Yes.
So when you add it to 156,000, what do you have?
16,000. Sorry,
16,
1,600,000, 2,240.
that's 100 and, did you say 160,000?
162,240.
Okay, 162,000.
240.
340. Okay. All right. So that's the value after how long? 2 years. Okay. So let's quickly run the same thing for Rachel. For Rachel's own, the difference between Rachel's own is just that it's 1.5%. So let me see if I can quickly do this. This makes sense. Oops. All right, I just wanted to do, I thought it might just be easier if I just edited stuff. Okay, so Rachel's own starts with 160,000, and then we're multiplying it this time by 0.015. Okay, so what would you get for the bracket side before we add it to 160,000?
2,400.
3,400. Okay. All right. So when you ask 160,000, that's going to be 163,400, isn't it?
Yes.
Like that. Okay. All right. So this time for the second year, we will have 163,400 plus 163,400 times 0.015 again. Okay. So what would you have now?
2,451.
Okay, that's for the bracket, right?
Yes.
Okay, so when you add that to 163,000, when you add that to 163,400, what would you have?
165,851.
Okay, 165,851 is said.
Yes.
Okay. All right. So that is it. I guess Rachel's own is has a higher value. So that's our conclusion. So do you have any questions on this?
No.
Okay. Okay. Moving on. Okay, sorry about that. Okay, can you still see my screen?
Yes.
Okay. Last year, a family recycled 800 kg of household waste. 57% of this waste was paper and glass. Weight of paper recycled, the ratio of weight of paper recycled to the ratio of weight of glass recycled is 12:7. Calculate the weight of glass the family recycled. How would you solve this problem? No, are you there?
Yes.
Okay, how would you attempt to solve this problem?
Sorry, I'm just writing down the question.
Okay.
Do you multiply the percentage by the amount first?
Okay. To get since he said 57% of this waste was paper and glass. Yes, that's the first thing we'll do. So 57% times 800 kg will give us the weight of waste that we should work with. So let's work that.
456.
156.
456. Okay. Good job.
Okay. Okay, so that the value for 57%
Yes.
of 800? Okay,
Yeah.
156. It should be more.
456.
Oh, okay, sorry, I heard 100. Um, okay, so 456 is the total weight we're working with. So our ratio is 12:7. So let's see. 12 plus 7 is 19, right?
Yes.
So the total, that's my denominator. My denominator will be 19. So what will we do? Because they said calculate the weight of glass the family recycled. So that means we're going to have 7/19 times 456, right?
Yes.
Okay, so can you quickly crunch that? Let's see what we have.
So 456 divided by 19.
Yes, 456 divided by 19, then times 7.
168.
Okay, so let me see. Let me just quickly do that here. 57 as 0.57 times 800. That gave us 456. Weight of paper recycled, the weight of glass recycled. So we now said 7/19. Yeah, times. Okay. So could you give me the value again? What did you say was the answer?
Equals 168.
168, right?
Yes.
So that's all in kilogram. Okay. All right. So I think what this is correct. So this is the weight of glass that was recycled by the family. So you got any question for this?
No.
Okay. So I think we can move on. All right. So it says here is a triangle and a rectangle. And the triangle is a right angle triangle. And the rectangle is, just a rectangle as it is. It says all measurements are in centimeters. Now says that the area of the triangle is 10 centimeters squared greater than the area of the rectangle. Work out the value of x. Okay. So I hope this doesn't lead us to a doesn't lead us to a simultaneous equation. Well, anyway, let's see. If the question says that the area of the triangle is 10 cm squared greater than the area of the rectangle, so we can form an equation from that. So what would that equation be? Let me see if I can let me use the text property. So do you understand what this question is saying?
Yes.
Okay. So now what's the formula for area of a rectangle?
Half times base times height.
For a rectangle, not a triangle.
Just base times height.
Base times height or in this case, length times breadth, isn't it? Since those are the dimensions that we usually find for a rectangle. Okay, so in this case, what's the length and what's the breadth of this rectangle? And I want to assume that the longest side in this rectangle looks like that 5, isn't it?
Yeah.
Looks like the side that is having the dimension 5. So this is what I'm going to do. Um, let's get the formula for the area first. So that's going to be length times breadth. That's 5 times, okay? Now remember, I'm using this method because that's what exactly it looks like. 5 times 4x minus 1, okay? That's the area of the rectangle. Now, since they said that the area of the rectangle, of the triangle, is 10 centimeters squared, greater than the area of the rectangle, that means if I add 10 centimeters squared to the area of the rectangle, excuse me, that will give me the area of the triangle, which is what? Half, and half is 0.5. Half base, and the base in this case is 8. And the height in this case is what? 6x. Okay, so this is the equation that I've been able to form from it. This is the equation I've been able to form from it. Let's see if we can now. Now this is what I want to avoid. I don't want us to. So please don't confuse the x with multiplication. All right. So this is what I'm going to do. Let's just go to the next line and represent this properly. Now, on the left-hand side, I have 5 into 4x minus 1. That's going to give me 20x minus 5, because 5 is going to multiply the 4x, and 5 is going to multiply 1. All this is equal to 0. Oh, my goodness, I've forgotten the 10. That's my bad. Plus 10, okay? All right, and all that is going to be equal to what? 0.5, which is half. Half times 8. Half of 8 is 4. And then 4 times 6x is 24x. So that will make it easier now. We're not confusing any multiplication with x. Okay. So do you understand it up to this point?
Yes.
Okay, all right. So next thing I'm going to do is I'm going to collect like terms, right? So the best way to collect like terms is for me to take 20x to the right-hand side. Do you agree with that?
Yes.
Okay. So that's going to leave me on the left-hand side with minus 5 plus 10. And all this will be equal to 24x minus, because the 20x coming over to the other side is going to be what? To become a negative 20x. So that's minus 20x. So that we're now left with minus 5 plus 10. Minus 5 plus 10 will give you what?
5.
Yes, 5. That's correct. Okay. That's going to be 5. And that's going to be equal to what? 4x. So we're looking for x. What would the final answer be?
4 divided by 5.
Yes, 4 divided by 5. And that is
1.2.
no, hold on. I think it should be the other way around. 5 divided by 4. Right?
Oh, okay.
Yes, it should be 5 divided by 4. I can't use this thing again. I have to use a math because I'll be dividing both sides by 4. 5 divided by 4 equals x. Okay, and that's going to be one whole number, 1/4. Okay, now we cannot leave the answer like this because it's in dimensions. So we're going to say x is finally equal to 1.25. Now, I want to ask a question. Do you know how I got the 0.25?
Yeah, divided.
Now, okay, but you know how I have the one whole number, right? The one whole number is as a result of this one whole number. Okay, the 0.25 is as a result of the 1/4. Now, let me explain it properly. The 1/4 says 4 into 1. So that's going to be 4 outside, 1 inside. 4 into 1 is 0 points. And then 4 into 10 is 2. 4 times 2 is 8. Okay? And 10 minus 8 is what? 2. We bring the 0 down. You add the 0 there. 4 and 20 is 5. 4 times 5 is 20. Sorry for that. Going to look into 20 minus 20 will give me 0. So that's how I got the 0.25. Do you understand it now?
Oh, yes.
So that's the final answer. That's what x is. Okay. So are you good with that?
Oh, yes, yes.
Okay. All right. So that's it. That's just the value of x. I know sometimes we like it when the questions always give us whole numbers. But yeah, sometimes it doesn't give us whole numbers, especially in this one where they allowed us to use what do you call it?
Okay.
When they allowed us to use, yes, the calculator. Okay, so can you, let's take a look at this. It says, write down, it's inequality, of course. It says, write down the greatest possible value of n. Now, remember, just like that question that we solved back there, n is a value between -2 and 5. Now, take note that there's equal sign on the left-hand side. That means -2 is inclusive. Do you remember when I explained this to you?
Yes.
When there's an equal sign, yes. So when there's no equal sign, like the side of 5, it's saying that 5 is exclusive. So if they say that we should get the greatest value of n, guess what? And n is an integer, then the highest integer that n can be is 4. Do you agree with me?
Yes.
Excellent. So this question is not even a tricky question. It's quite clear. It's just the only thing now is for one to understand. Now, if this question were to ask, what is the lowest value? What would you say is the lowest value of x?
-1.
No.
Wait, if it's already
The
-2.
lowest value is -2, correct? That's it. That's the lowest value it can be. Because of, now, let me explain. You see these signs, the less than or equals to and less than, okay? What it's trying to say is that -2 is less than or equal to n. So that means n is greater than, if you want to interpret it in terms of n is greater than or equals to is greater than or equals to -2. So that means it can only be from -2 upwards. Okay. Then the less than 5 is like, this is where it stops. It cannot go beyond 5. Did you get that?
Yes.
Okay. So that's the answer for that guy. The second question says, on the number line below, show this inequality, -4. Now, this one is even, it's even simpler. If I have to show the inequality, this is what I'm going to do. Remember what I said that time. You draw a line just to make it easy for you. Draw a line upwards from -4. Draw a circle, a small circle will do. Doesn't need to be a big one. And then less than 1 is the edge of it. So you're going to draw another one, another line from 1, and draw a small circle there. Okay. Now, you can use a straight line to join it, because that straight line is saying all the values between -4 and 1 are what we're looking at. Now, because there's an equal sign on the -4 part, we're going to do what? We're going to color this side. You remember what I said about coloring the circles, right?
Yes.
Coloring the circle means that that value that's there is also included. But I'm going to leave this one uncolored or without a color, because there's no equal to on this side. Okay, so did you get that?
Yes.
Excellent. All right, so I'm moving on. The next one is a question that says you should solve that equation. Sorry, I don't know why this thing is. I think I mistakenly zoomed out. Okay, can you still see my screen?
Yes.
All right, good. Okay, so to solve this question, first thing that I'll do is to write it out. But I think that's the best practice to solve any algebraic question like this one, which is an algebra with inequalities in it. It's best to write it back first. Okay, so solving it, if you have a fraction, anytime you have an algebraic equation and you have a fraction, always understand that you must take care of that denominator, whatever is in the denominator first. So in this case, thank God there's only one denominator. So what are we going to do to that denominator? We'll multiply all the terms by that denominator. So in this case, I'm going to multiply 2/5 by 5. Okay, so what that means is that, I want you to just imagine this. I multiply 2/5 by 5. So this is how it's going to look. 5 times what? 2/5. What do you think will happen? When you multiply 5 by 2/5, what will happen?
Wait, that's how it's supposed to happen.
What did you say?
I learned how to calculate it, but I don't remember. I didn't learn how to do this way.
Okay, they will cancel out. they'll cancel out. 5 will cancel itself out. That's the whole idea of saying multiply all the terms by the denominator. That's the only denominator. So that's the whole, do you get it now? So that 5 will cancel itself, leaving you with 2 alone, 2G. Now, on the other hand, all the other ones will still have to deal with multiply by 5 because you have to multiply all the whole terms by what? The same thing. Did you get that?
Yes.
Okay. Now, let me just say something. It didn't happen here, but let's say that you have a situation where this 4 were to be 4 over, say, 3. Okay. And now you now have 5 and 3. I mean, let's imagine that that was the question. Then you will not just multiply all the terms by 5. You multiply all the terms by the LCM of 5 and 3. Okay. Most likely that would be 15. Okay. So that would help you to get rid of both 5 and 3. But in this case, thank God that it is just 5. So we will deal with the 5 alone. So we're going to be left with 2G minus 20 less than 30. Okay, so do you understand it up to this point?
Yes.
Okay, so next step, we're going to have 2G. Now, I told you something about inequalities, that an inequality is simply like an equation, but it's just that it has what? Inequality signs in it. So collecting of like terms will still happen for this guy. So if we're going to collect like terms now, this minus 20 will go over to the right-hand side, leaving me with, it will become 30 plus 20. The same thing that would have happened if that inequality was an equation. Okay, just collect the like terms. So we're left with 2G here again. Now, did you notice something? Did you notice that the sign didn't change? You know, I told you that for inequalities, the unique thing about them is that signs can flip, isn't it? So less than can become greater than. Like in this case, less than can become greater than, or greater than can become less than. But the reason why nothing has happened so far is that none of the conditions for that to happen have been met. Okay, so that's the reason why you didn't hear me saying signs, the less than sign will now become greater than. So remember the rules. I think I stated it for you in one of those questions. The only time a sign, inequality sign, can change from less than to greater than or vice versa is when you are either multiplying or dividing by a negative number. None of that has happened yet. Okay, none of that has happened yet. So that's why the sign is still the same. Okay, then I think I also gave you 2 other instances where that can happen. Second instance is when you take the reciprocal of both sides, or you invert both sides. And then the last instance is when you change the position of the variable on both sides. Okay, so none of that has happened. So that's why I didn't change anything. So back to the question. 2G will be less than what? 50. Now we're looking for G. What are we going to do to both sides?
Divide them by 2.
Thank you very much. So we're going to divide both sides by 2. Again, none of the conditions for changing the sign have been met. So 50 divided by 2 is 25. Okay, I'm sure you know by now how I got 25. If you want to still go down to the basics, 2 in here, 2 in itself, 1. 2 in 5, 2 times, remainder 1, because 2 times 2 is 4, and 2 into 10 is 5. So G is less than 25. That's the final answer. Okay. Now, I'm just going to take this question a step further The question didn't ask us to do this. The question could have said, also represent your answer as a number line on the number line. And this is quite simple. All you just need to do is to draw a number line, indicate where 0 will most likely be. Okay, so we're just looking for crucial points. 0 is a crucial point. Why? Because it separates negative from positive. And since 25 is on the positive side, we'll just guess where 25 can be. Okay, nobody's asking you to draw something that will exactly be how it should be in real life. Just do a guess, okay? You can put 25 anywhere you want, as long as you put it on the correct side, which is that it's a positive number. Then less than is pointing towards the left. I'm sure you've noticed that. So the graph this would look something like this. Did you see that?
Yes, yes.
Did you notice that I didn't draw another line from anywhere to come and meet this line up here? I didn't do that. Why? Because this is an open-ended inequality. There's nothing on the left-hand side of G saying something is, do you understand? There's nothing like that. So that's why I didn't, let me clean it before it looks like I did something there. Did you get what I just said, what I just explained?
Yes.
Also, take note, there is no equals to here because I didn't see any equals to in the question. So that's why I did not color this circle. I didn't shade it. Okay. So please take note of these little things. They are the things that count when it comes to inequalities. Okay. Any question on this? Any question?
No.
Okay, good. So we're moving on. All right. Okay, this one looks like maybe there will be something product of prime numbers and then probability. Okay. It says there are 48 counters in a, oh, sorry, let me go with the product of prime factors. So I'm sure you can do this, right? 60 is equal to, the easiest thing we know is 6 times 10. Am I right?
Yes.
Break down 6 times 10. 6 is 2 times 3. 10 is 2 times 5. So prime factors, 2 squared times 3 times 5. Sorry, I just, let's see if I cancel it. Okay, thank God. All right, are we good with this?
Yes, thank you.
Okay, good. All right, so moving on. There are 48 counters in a bag. There are only red counters and blue counters in the bag. Number of red counters, ratio of number of red counters to number of blue counters is 1:2. Helen has to what? Helen has to work out how many red counters are in the bag. She says there are 24 red counters in the bag because 1 is half of 2 and 24 is half of 48. Okay, is Helen correct? You must give a reason for your answer. This is a tricky question, right? But if we understand what ratio means, I think Helen is not correct. What do you think?
Yeah, no, it doesn't. She doesn't look correct.
Helen is not correct. So the reason is quite clear. If you look at it very well, I mean, a ratio of 1:2 means that the total parts that we're dealing with is what?
3.
Is 3. So it's actually divided into 3, not into 2. So that's where Helen kind of got it wrong. He got it really, really wrong. So it should be 3 parts. So it's not 24. It should actually be 1/3. If we divide 48 into 3, that's going to be 16. So that means it's going to be 16. It's going to be 16, 16. It's going to be 16, 16. Okay. 16, 16, 16. So it's actually 16 to 32 and not 24 to 48. But how do we explain the reason for the answer?
Well, because it's 3, you can just say 1/3.
Yes.
Half, not one half.
Yes. 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 Okay. Okay. So I think we can, this one is more of an explanation thing, really. It's just testing your understanding of ratio. Okay, wow. This one looks, okay. So can you do number 20?
Yes.
Okay. So which one would you do first? Because this one really is counting on your understanding of hierarchy.
I should do it.
Yes. Or do you want us to skip it?
We can skip it. Yeah, we can skip it.
Okay. Okay. All right. Now, let me see. Do you have an understanding of the next one?
About your orders. Cool. No.
Reciprocal. You've heard me talking about reciprocal severally before, right?
Yes.
Okay. So, reciprocal simply means making the denominator the numerator and making the numerator the denominator. Now, I'm sure you're thinking, this thing doesn't look like it has a denominator and it doesn't look like it has a numerator, right?
Yes.
So what would I be talking about in that sense? the only way to show denominator and numerator in this kind of thing is simply to we're going to turn it to a fraction. Now, if I were to turn 0.625 to a fraction, what would it become? Do you remember how we turn decimals to fraction?
Is it 1?
The decimal point, you use 1 to represent the decimal point, and then put 0 under the remaining digits, isn't it?
Yes.
So that's 625. As a fraction, this guy is 625 over what? 1,000. Agree?
Yes.
Okay. So can you quickly flip this? The reciprocal of this, reciprocal R, is going to be equal to 1,000 over what? Remember, numerator becomes denominator and denominator becomes what? Numerator. 1,000 over 625. So can you do that with your calculator? What did you get?
8 over 5.
8.5.
8 over 5.
8 over 5.
8 over 5 and
Okay.
then equal 6.
Okay. Can you turn it to a decimal? Let's see.
Equals 1.6.
1.6, you said?
Yes.
Okay, excellent. So that's going to be equal to 1.6. Okay. Okay. So are we good with this?
Yes.
Okay, so I'm moving on to the next one. All right. So it says 240 people work at a factory, right? Of these people, 150 have a car, 110 have a bicycle. 65 of the people who have a bicycle do not have a car. Use this information to complete the frequency tree. Can you do this? Can you do this one on your own?
Yes.
Okay. Okay. So I think we can move on. How about these ones? Can you work these ones out? Or would you like us to look at them?
Yeah, we can go for.
Can we move on?
Yes.
Okay. Okay, let's just look at this one. It says there are 3 cinemas, A, B, and C. The mean number of seats per cinema is 380. There are 350 seats in A, 250 seats in B. Work out the number of seats in cinema C. Okay. Now, I don't know why this question is looking tricky to me, but do you understand what this question is asking for?
Oh, no.
So mean, right? Mean is a what they call that thing in statistics, measure of central tendency. What that means is that, for instance, now, if mean seats per cinema is 380, they're saying that we added the number of seats in A to the number of seats in B to the number of seats in C. We now divided it by 3 and we got 380. Do you understand that?
Yes.
Okay, so let's see. If you understand it that way, then let's write down what we have. 350, right, plus 250, that's the number of seats in cinema B, right, plus how many in C? Let's just use the letter C to represent the number of seats in cinema C, divided by 3. And all this is equal to what? 380. That's what the question told us, that the mean number of seats. And I told you another name for mean is what? Is average. Yes, average. So with this in mind, what's the first thing I'm going to do in this equation?
Change, rearrange.
I didn't get you. What did you say?
Rearrange.
Okay. So if you look at this equation properly, okay, the first thing you will need to do is to take care of the 3. Okay, is the 3. So first things first, let's take care of that 3. You remember how we took care of 5 when we had 5 on the other side? We multiplied both sides by 5, right? So in this case, we're going to multiply both sides by 3 so that 3 will cancel what? 3. And on this side, I have to multiply here by 3. So help me with your calculator. Multiply 380 by 3. What will you have?
100, 1,000. Sorry, 1,140.
1,140. Okay. So what I'll be left with is 350 plus 250 plus C. That's what will be left on the left-hand side, equals 1,000. Sorry, come again with that value again.
1,140.
1,140. Okay. So when you add 350 to 250, I think you have 600, right? So that's 600 plus C equals 1,140. Okay, so C will be equal to, what would I have? What would I have for C?
540.
Okay, that's right. So if you wanted to show your steps, yes, you're right about the 540. That's 1,140 minus 600. So that would be 540. Okay, so we're good with this, right?
Yes.
That's 540. Can you do this one?
Speed. Speed multiplied by time equals distance.
Exactly, exactly. Speed multiplied by time equals distance. Okay. How about this one?
Um, no, I don't understand that.
I think this one has to do with probability.
Oh, okay.
Any idea?
Yeah. Yeah, we can skip it. It's fine.
Okay, all right. Okay, what about this one? Packets of sweets are put into boxes. Sorry, take a look at this one. 1 minute, please.
I'm done. It's 2 hours. Yeah.
Hello, no, are you there?
Yes.
Okay. All right, so can you do this one?
No.
Okay, so let's work on it. For this one, right? If packets of sweets are put into boxes, and each box is the size of the smaller box on the left, then I want you to imagine this. The question is, work out the greatest number of packets that can be put into each box. So let's see. Another way of asking that question is, how many of the small box can fit into, how many of the packets, sorry, can fit into the box? So that sounds like a division question to me, isn't it? It sounds
Yes.
like a, yes, division. But now you have to be careful about it. You know why? Because the units are different. Now, this is what I mean. For instance, we know that 10 millimeters make 1 centimeter, isn't it?
Oh, yes.
10 millimeters make 1 centimeter. So that means that the real dimensions for that small guy, the packet, is actually 8 cm by 6 cm by 2 cm, if we're going with the 10 millimeters make 1 centimeter thing. So that makes it quite easy for us, since we've now converted it to, let me see, we've converted it to what? Centimeters. So let me just write it here first so that we have an idea of what we're dealing with. 8 cm by 6 cm by 2 cm. Okay. Now, the question is, how many of these can enter that packet? So this is what we're going to do. Now, I want you to look carefully at the drawing. You see, that's why they gave you the sketch. It's not just a division question. I'm trying to be careful now about how we go about this. There's also an issue of what? The dimensions. So the 8 cm is the downside that matches with the 72 cm bit. The 60 cm or the 6 cm, the 60 millimeter part or the 6 cm part is the part that matches with 48. And then finally, the 2 cm part is the part that matches with 24. So we're first going to find out how many 8s, how many 8 cms can fit the 72 cm part. And that's going to be what? 9. So let's start with that. Okay, so I want to, in your minds, I want you to imagine 9 8 cms in that 72 cm part, right? Then let's look at the 48 cm part. That's corresponding to 6 cm. We're looking at the floor of that box now. So how many 6 cms can fit 48 cm? That's going to be 8, isn't it?
Yes.
Because 6 times 8 is 48. I hope you understand how I'm going about it now.
Yes, I do.
Okay, good. All right. Then let's now see how many 2 cms can fit the 24 cm part. That's going to be 12. That's 2 times 12, which is 24. So that's 12. So that's going to be 9 by 8 by 12. And that's going to give us what? 9 times 8 is 72. 72 times 12 will give us what? Can you help me crunch that with your calculator?
864.
864, and that is the number of packets that can fit each box. Do you understand it?
Yes, yes, thank you.
All right. Okay, so I think we can move on, right? Or do you want me to say more things about how I got the 9, the 8, and the 12? Do I need to say more about that?
No.
Okay, you understand, right?
Yes.
So, but then I'm big on making sure that your workings are seen. So maybe this is what I'll do. I'll just write this 72. Sorry, let me keep writing to 72 cm. How I got the numbers over 8 cm. That's how I got 9. To find out how many 8 cms will fit there. Then how did I get 6? 48 cm over 6 cm equals 6 times 8, 48. And then finally, 24 cm over cm. That's how sorry, let me put the cm part so that I don't forget. Cm. And that will give me 12. Okay. All right. So moving on. Okay. How about this one? Something you can handle?
Um,
Okay, don't worry. Let's do it together. It says there are 50 teachers in a school. This is 1/16 of the total number of people in the school. And they now ask us, what's the total number of people in the school? Ideally, this is a question that you can just simply say, let the total number of people in the school be the letter T. That means that 1/16, and remember that in mathematics, of means what? Multiplication, isn't it? Am I right?
yes.
Okay. Okay, so I hope you can see that what I just did here is T over 1 and not looking, I hope it's not looking like something else. Let's total, I'm not going to write everything there. I'll just write, let total number be T. The capital letter T. So from the question, it says 1/16 times T over 1, because that's what it says. 1/16 of, please always remember of means multiplication. 1/16 of the total number of people in the school is 50, because they said that they're teachers, okay? So since they are just referred to them, 50 teachers. So question is this, what is the value of T? So let's work on this guy. T times 1 is what? T, all right? 16 times 1 is what? 16. So T over 16 equals what? 50. Okay? So you're looking for T. What will you do to both sides?
Multiply by 16.
Thank you very much. You multiply by 16. So therefore, T would be equal to 50 times 16, which is, you can use your calculator to crunch it. 800, right?
Yes.
Okay. So let's just put the number here. 800. Nice. So can I leave this one for you to handle?
Yes.
Transformations. Okay. Okay. Okay, so let's see. The table shows information about the weights of the people in a hotel lift. Show that the total weight of the people in the lift is less than 1,200. All right. Let's look at the table again. It says 40, only, okay, one person is 40. Two people weigh 50, 4 people weigh 60. Okay, it's very simple. I think what we now need to do is to multiply the number of people by their corresponding weights, isn't it?
Yes.
That's it. There's no other way to show that it's less. That's just it. Okay. Okay. So that's sorry, let me just use this thing and do it. I think text, make it faster. So that's going to be 40 times 1. Okay, I wrote 49. Okay, 40 times 1 plus 50 times 2 plus, oh, sorry, I think I went and press E beside plus. Okay, plus 50 times 2 plus 60 times 4 plus 70 times 5 plus 80 times 3, and finally plus 90 times 1. All right, so while I can do this, I think I have, that's going to give me 40 plus 100 plus 240 plus 350, because 7 times 5 is 35, plus 240 again, because 8 times 3 is 24, plus 90 times 1 is 90. Okay. So now I know this is a calculator paper. Okay. The calculators are permitted, right? So you can go ahead and add this up. What would you get?
$1,060.
1,060, right?
Yes.
So you can see that 1,060 is clearly less than 200, isn't it? 1,200, sorry. That's the only proof. I wish there was another proof, but that's the only proof. That's the only way I can go about it. Okay. This one is a graph. Let me see if it's something that you can easily handle. This graph can be used to find the cost of parking a car in a car park for up to 12 hours. It says use the graph to find the cost of parking a car for 4 hours. Okay, that's quite simple. You look for the number of 4 hours and trace it to the graph. That should be £6, isn't it? Well, I think this one should be relatively simple for you. So I can skip it, right? Or do you want us to do it together?
Yeah, can we do it, please?
Okay, should we go ahead?
Yes.
Okay, so I think I've already answered the first one. Use the graph to find the cost of parking a car for 4 hours. That's trace 4 up and then trace it to the graph, which is, let me use this thing to just draw it. Trace it to the graph and then trace it to here, and that will give us 6 hours. The next question says, sorry, £6. Sorry. Then the next question says, Justin drives into the car park at 8 in the morning. When he drives out of the car park, he has to pay £9. At what time does Justice drive out of the car park? Now, if you go and trace £9, £9 will be somewhere here. So if I trace £9, I'm just guessing. No, I'm not guessing, I'm sure. If I trace £9 to the graph, I trace £9 to the graph, this is where I would land. And that would take me to how many hours? That would be 6 hours. So in other words, I'm going to add 6 hours to 8 o'clock in the morning. 8 plus 6 is 14. Okay, so let's just do this. 8 plus 6 is 14. 14 according to our British time. No, let me not add it that way. Let's add it this way. Plus 6 hours, because it will look ridiculous if I put it down there. Okay. 8 plus 6 is 14, and 14 is what? 2 p.m., isn't it?
Yes.
Okay. So either you call it 2 p.m. or 14:00 hours. Or I think if you just say 14:00, that's fine, which is the same thing as what? 2 p.m. Okay, I think we're done with this question. Quite simple. I saw those, like that paragraph, it was looking like it was going to be more challenging. It says here are the first 5 terms of a sequence: 3, 8, 5, 3, 8, 13, sorry. Okay, it looks like we're just adding 5. It says write down the next term of this sequence. So can you handle this one? It's an arithmetic progression, isn't it?
Yes.
So it looks like we're just adding 5 and 5 and 5. So what would the next term be? If I add 5 to 23, what would it be?
28.
28, right? Okay. Okay, next. It says write down the ratio of the second term to the fourth term. The second term is 8. The fourth term is 18. Second term to fourth term is 8 is to what? 18. Yeah, and they said we should give it in the simplest terms. So let's break it down. 2 in 8 is what?
4.
4. 2 in 18 is what?
9.
9. So that's 4 is to 9. That's the lowest, simplest form you can have it, right? Okay, we're moving on. Okay, we're almost there. The diagram shows 3 motorway service stations, P, Q, and R on a map. It now says, the map has a scale of 1 cm to 4 kilometers. Okay, so that's every 1 cm represents 4 kilometers. It says work out the real distance from P to R. That's simple now. 16 plus 8 is 24 centimeters. If each of those centimeters is 4 kilometers, then the real distance will be 24 times 4, right?
Yes.
Which is 4 times 2 is 8. 8 plus 1 is 9. That's 96. Am I right?
Yes.
All right. So that's, if you want to show your working, please always remember, it looks like your this exam emphasizes on working. So we should avoid, yes, it's good to do mental maths a lot, but if a question is big on show your working, then I think it's just ideal that we show our working. So the real distance will be equal to 24 times 4. So that's 96 km. All right, so we move on. Triangles have come again. Here's a triangle. The triangle is accurately what? Drawn. Measure the length AC. Okay, I'll have to leave this one for you. It needs a ruler, and I don't have a ruler on this. I don't have a ruler on this there. So you can handle it, right?
Yes.
Now, let me just say something, please, before I leave it, because I'm looking out for any tricky, because sometimes when a question looks too simple, you look at it, there's a small caveat there. And that caveat can look like anything that will want to trip you up. Now, the caveat for this particular question is this second one, where it says here is a different triangle. Now, to measure the size of an angle, right? The size of an angle, you need a protractor. I'm sure you have a math set by now. So you can use your protractor in that math set. But the part that needs you to do a bit of real thinking is this part where it says, here's a different triangle. It now tells you that QP is this side, is equal to QR. QR is this side. Now, the only kind of triangle that has two sides equal is what? Do you know that? Do you know the name of that triangle? A triangle that has two sides equal. Isosceles. Okay. All right. So it's an isosceles triangle. Sorry, my isosceles triangle. Okay. Now remember, isosceles triangle has two sides equal, and by extension, it's the two angles that are touching those two sides will also be what? Equal. Okay, so this angle will be equal to this angle. All right. Now that's for an isosceles triangle. For an equilateral triangle, all the sides are equal, all of them. Okay, so please don't forget that. So like I said, I'll leave the rest for you. Measuring things should be something that you can do quite simply. Okay, so do you think you can do number 6? Take a look at number 6. Can you tell me what we'll do there? Hello, Noah, are you there?
Yes, I said does she cross out? Sorry, should we cross 0?
Okay, let's look at the question. Let's look at the question. It says she rolls the dice once. She has a fair ordinary dice, and we know a dice has 6 faces and has different numbers on those 6 faces from 1 to 6. It says on the probability scale, mark with the cross X the probability that Shari gets the number 7. Yes, you're correct, because there's no face that has 7 on it. So yes, we're going to cross the 0 part. You're correct. Okay. So on the probability scale, mark with the cross X the probability that Shari gets an even number. So how many even numbers do we have from 1 to 6? 2, 4, and what? 6, isn't it?
6, yes.
What's the formula for probability? Do you remember?
Input divided
Formula
by
for probability. I didn't hear you.
input.
Input. When you say input, maybe it's the term you decided to call it, but I would rather call it the outcome. But probability is number of required outcomes over number of possible outcomes. Okay, so I always tell you required outcomes, right? Required outcomes depends on the question. In this case, it's asking you for what's the probability of Shari getting an even number. So how many even numbers are possible? Because that's what the question wants. There are 3, isn't it? So that's what they're going to put on top. Number of required events means number of even numbers. And in this case, the number of even numbers is 3 because I can only count 3 here. 1, 2, and 3. The number of possible events is the total number of possibilities ever. And in this case, it's 6 because there are 6 faces in our die. And 3 out of those faces are even numbers, whereas there are 6 in total. So 3 over 6 is as good as what? 1 over 2, isn't it?
Yes.
So we're going to be marking here, right? Half. Are we good with that?
Yes, yeah.
Okay, please don't forget let me write down, I think I've written that down for you before, but let me write it down again. Number of required events. And I told you that required events depends on the question. Over number of possible events. Okay. Let me just put in brackets. Total. Oops. Okay. Number of required events. Question. All right. So let me move this closer. Let me move this closer. Okay. Then this is formula for probability. Okay. All right. That's just a reminder. Please don't forget it. But when you are solving it, please, there's no need to write down the formula. I'm just writing it down to remind you. Okay, just the one that is expected for you to write down is what I've written down already. 2, 4, and 6, showing them how you got the number 3, that there are 3 possible even numbers. So probability of even will be the number of required events, which is 3 even numbers, over the number of possible events, which is 6 spaces. Possible events, that's 6 spaces. That's how you get 1/2. Okay, so wow, we are finally at the very, very, very top. This is what I wanted to start before, but yeah, I think it was good that we start with the tougher ones. Okay, so write down 6184 correct to the nearest 100. What would that be?
6,200.
Yes, correct. 6,200. Next, write down 0.7 as a fraction. I think we have done something like this. When you remember when we looked at 0.625, we said what? Treat the decimal point as what? 1. And then put a 0 under the other numbers after the decimal point. And so that's going to leave us with what? 7 over what? Over 10. Correct. So that's the answer. You cannot break down 7 over 10 again. So that's the lowest it can ever be. And we're grateful for that. Change 9 meters into centimeters. What's the conversion measure for this guy? 100 centimeters
Equals 1
make
meter.
what? Yes, correct. Equals a meter. So if I want to convert from meters to centimeters, that means I'm going in this direction, isn't it?
Yes.
So, and that means I'm going from 1 to 100. That looks like multiplication to me, right?
Yes, yes. 900.
So that's going to give me 900 centimeters. Okay, moving on. Simplify 3 times 40. I mean, without even blinking. That's 12t, isn't it? When you're doing, I want to it's just a reminder. I know that this is not something that should confuse you. When you're dealing with multiplication and division, you notice I don't usually, especially in scenarios like this, we don't usually say collect like terms. But if you look well, when you're dealing with addition, whenever we're dealing with addition and subtraction, that's why you usually see me saying collect like terms, okay, because it's addition and subtraction. But when it comes to multiplication and division, like terms don't really apply like that, except if there's addition and subtraction somewhere in the picture, okay? But like terms don't really apply here when it comes to multiplication or division. And you can think of multiplication and division as cousins, while addition and subtraction are equally cousins too. Or should I say, I don't even know how to qualify them. There's a way I used to remember it. So I think I said addition and subtraction were like brothers and sisters, while multiplication and division are like brothers and sisters. Then if you want to talk about in terms of how they behave, addition and multiplication seem to be increasing things, while division and subtraction seem to be reducing things. So that's in terms of behavior, okay? So yeah. All right, but did you get what I just said back there?
Yes.
Okay, good. Okay, so here's a list of numbers, 20, 40, 60, 80. Yes, we know that those are even numbers. There's one of these numbers is a multiple of 25? Which number? Oh yeah, look at these numbers. Which one do you think is a multiple of 25? Just by looking at it. You must have done a lot of calculations with this thing. This question is just testing your knowledge basically with numbers. There's a number that you have done a lot with that found you saying that number times 25 so a number times 25 will give you that number. Which number is that? Now let me just tell you something. If you are stuck in the exam, you are stuck, you don't know what to do, and you have your calculator with you, what I will advise you to do is to divide each of these numbers by 25. Obviously, there's no way 20 can be the answer. Why? Because 20 is less than 25, and a multiple must be bigger than the number that it belongs to. Okay? So 20 is less than 25, so 20 is out of the picture. 40 is equally out of the picture because I already know that 25 times 2 is 50. And that's the law. I mean, if you multiply something by 2, you multiply a number by 2, and the number that you're testing it for is less than it. I mean, what there's no need to check it. So 40 is out of the picture too. Now, because 50 is 25 times 2, then there's no way 60 can be the answer, because the next multiple we're heading for 25 will be 25 times 3, which is 75. Okay, so obviously 8 is out of the picture because 75 has already met the condition. The next number that is left out of this thing is 100, and 100 is a perfect fit because 100 is 25 times 4. Did you get that?
Yes.
Okay, so 100 is the answer. And I hope they will not ask you to start showing working. But if they ask you to show working, then it's very, very simple. A multiple of a number is simply the number that when you divide that number by, for instance, in this case, if 100 is a multiple of 25, then 25 will go into 100 exactly 4 times without a remainder. 4 remainder what? 0. Okay? There's no remainder. All these other ones, we have remainders, all of them. So there's no point testing it. This is just enough. I don't know whether they want you to show any working, but I don't see any space for working here. So yeah. Okay. So I think I should be sending you this, right? Let me say
Yes.
save as. Okay. Annotated. All right. Okay. All right. So I've saved it. Okay. So your mom contacted me earlier today. She said that you would be available tomorrow too, right? You will be at home tomorrow too because of the exam. So did she tell you we'll be meeting in the morning?
Yes.
Okay, so I usually, like I told her, that I have a meeting by 10 o'clock. That meeting usually lasts for like 30 minutes. So after the meeting, I'll let you know. So just be close to your phone around 10:30. So as soon as I'm done with the meeting, I'll send you a message that I'm ready to connect. So we can start our class by 10:30 so that we're done by 12:30 at the least. Okay. So and then so that means we'll be having, yes, so that means we'll be having 2 classes tomorrow, the morning and in the evening. Okay, so I'm thinking now, right? You'll be on the site that you were able to source this 2023. You should be able to source 2022 and 2021, right?
Yes, yes.
Okay, so that will give us material to work with tomorrow, so that we'll have we'll be able to do a lot of questions tomorrow. Okay. All right, so I'll be sending you this one on WhatsApp. Let me stop sharing my screen.
Yeah, thank you.
Okay, do have a restful night. See you tomorrow.
Thank you. You too. Bye.
Okay, bye.